Just want to maybe get some thumbs up in the chat if everybody can hear us properly. I'll maybe let my colleague Jellica do a mic check as well.
Yeah. Good afternoon.
Okay, thank you for the thumbs up. Thank you. Lots of thumbs up. Perfect, perfect, perfect. Pleasure to have everybody join us today. For those of you that are in Ontario or looking at developing in Ontario, these are some exciting times. Many of you may know that Ontario was the first province in Canada to really invest in renewables, invest in the solar industry back during the RESOP and the FIT program. There's been obviously a little bit of a hiatus in terms of activity here in the province for a number of years, but those of us in the industry are very excited to see the industry coming to life again. As many of you know, this is one of the largest procurement initiatives by the province for power, so everybody is quite excited. Our goal here today is to talk through some of the items that should be considered when looking at a site to determine if it is a feasible site, if it is a good site to put forward as part of the RFP program, to develop an understanding of items that could become problematic and cause design and construction constraints that could result in costly designs and or facilities. Next slide, please, Livia. So to introduce our speakers, I'll let Jellica introduce herself, but myself, I'm one of the founders and chief operating officer of PRI Engineering. I'm a geostructural engineer. I've been involved with hundreds of geotechnical investigations, both for non-renewable projects, but also for solar projects. As an organization, we've worked from as far north as the Arctic Circle to as far south as the Caribbean. We're very, very diverse with work taking place in North America. And I'll hand it over to Jellica to introduce herself.
Hi, everyone. Excuse me. Hi, everyone. My name is Jellica. I'm the program manager of the solar engineering department based out of Calgary, Alberta. I am a licensed professional engineer myself, mostly focusing on the geotechnical aspects, and majority of my career I've spent working on solar projects, as Arash mentioned, from coast to coast, as far north as Northwest Territories, Inuvik, and as far south as the Caribbean. We have been involved on every stage, as early as the feasibility, investigations, detailed design. I've also been involved in construction, QA/QC, for operating solar facilities, and even post-construction, investigating remediation designs and such. Um, that's it for me. If we can move on to the next slide here. I'll let Arash introduce the company.
Yeah, so we were established in 2019. We're definitely specialists in the field of solar foundation racking design. However, because of our involvement in a number of projects, we have a very good understanding of the permitting process, risks that could arise and cause problematic conditions for a project. We are going to talk through a number of those items, but for each item, we are going to kind of close off with discussing the implications that would arise from a geotechnical engineering structural standpoint. We've done over 300, we've done over 500 projects. Probably about 60 to 70% of those are solar farms. We do have an in-house soils, concrete, aggregate laboratory, both in Ontario and in Alberta. And we also have an import permit allowing us to bring in materials into Canada from other countries for doing laboratory analysis on them. And we've got a team of 35 individuals, ranging from environmental geoscientists all the way to geotechnical engineers and structural engineers. Get the next slide, Olivia.
Okay, and a little agenda for today here. We prepared 4 main topics for you to consider during the permitting process. We purposely prepared just 1 slide for each topic here because we want to make it more open-ended, and at each slide we'll pause and give you some time for questions, so we encourage a lot of participation. On the first slide, we will be talking about environmental and regulatory considerations. So the very first thing to consider is whether this site is a no-go from an environmental perspective before moving on to the other considerations here. Secondly, we will look at site selection and topography. Third, access. So thinking about access roads on and off site, site layout considerations for all your racking structures, electrical equipment. And for the fourth topic here, a little more on the operational and maintenance side of things from a more longer term perspective. So I will let Arash take on the first topic there as we move on to the next slide.
Okay, so looking at environmental and regulatory considerations, this is one of the first items you want to consider because, in a lot of cases, when you're going through the permitting process, you're working through land control, you've got a potential site in hand, and then you want to actually start looking at some of the physical features to see how feasible and how large of a system you can put in place. So, a very common first step is completing a species at risk and wetland survey. So species at risk, that could be birds, frogs, turtles, etc. One thing that you want to kind of really consider here is that screening for some of these species at risk, typically it starts with a desktop review. And from the results of the desktop review, it could trigger the need for physical on-site screening programs. That might involve doing, like bird watching or bird screening. Physically looking for nests or other physical features on the site that would suggest that not only is this a probable habitat for that potential species at risk, but also, there's signs on the site to show that particular species is actually likely physically there. So that's one thing. We've seen a lot of projects across Canada and even into the United States where there was, significantly large parcels of land, but a lot of those areas were considered off limits because of a certain bird nest or a habitat for some sort of turtle or amphibian or anything. So, these things can be project killers, and that's why it's like very important prior to spending any valuable development money to look at these items. Same thing with wetlands. Here in Ontario, there is a very good record of wetlands in the public database. That being said, does not mean every square inch has been scrutinized. That could mean there's provincially significant wetlands, there's registered wetlands, and then there's unclassified wetlands, and then on top of that, you got the fourth category, which is like wetlands that would be on the site that are have not been documented in any shape or form. So, the technical definition of a wetland, there's 2 of them. One of them is that there's more than 50% aquatic vegetation, versus terrestrial vegetation. And so obviously that is a survey that can only be completed in the months where there is vegetation on the site. You could not do a wetland classification delineation based on vegetation in the winter months. And another methodology that is used in Ontario to distinguish wetlands is actually more of a geotechnical has more geotechnical input, and that's where you have sites which are predominantly saturated over the course of the year, and most importantly have a minimum of 20 centimeters of organic soils at the surface. So then beyond that, you want to be consulting the conservation authorities. So the conservation authorities in Ontario do have kind of two primary mandates as it would relate to permitting projects. One of them is the presence of hazard lands. So hazard lands are potentially steep slopes that are adjacent to protected waterways or within flood areas. The hazard lands, the conservation authorities around Ontario, they have a lot of mapping that kind of identifies if a certain area has a hazard land or not. Just because it's been identified on their mapping, it doesn't always necessarily mean it is the case. It just means that you would need to have further investigation potentially to determine what special considerations need to be made around those potential hazard lands. So that would be looking at the slope, checking it for erosion, checking it for stability issues and concerns, and whatnot, and determining how that would affect the structural design of the facility. Waterways and wetlands, simply put, you just can't build in these features. There is some other challenges with them, which I'm going to let Jellica speak to in a little bit here. But ultimately you need to kind of understand where those features are, because from those features you are then going to develop setbacks, which until you've got kind of your environmental setbacks, there's also typically also property setbacks that need to be considered from neighboring properties. But until you establish all these setbacks, it's very difficult to start finalizing your site layout. And without kind of finalizing your site layout, you can't establish your proposed generation size. And at that point, it doesn't really make sense to be doing any detailed work on site until you've got as a minimum the area that's been identified, which has some of the setbacks considered. And that's why obviously this is all one of the first steps after you do have land control in place. I just hand it over to Jellica to maybe comment a little bit more on how this affects things from a geotechnical engineering standpoint.
I think, Arash, we had a hand.
Oh, we do have a hand.
Yeah. Maybe you'd like to take on a question first before we go into
Sure, absolutely. Yeah. Okay. So I think the question from Matt Pepper. Thanks for joining, Matt. So does species at risk include insects? It does. That being said, in all my years, in all my years of working on projects, I don't recall a case when an insect derailed a project. I've seen snakes derail projects. I've seen turtles derail projects. I've seen birds derail projects. However, insects is not one that I have come across. So, I would suggest that they are species at risk. However, I'm not being a biologist. I'm not 100% sure how you would handle that 100%. Hopefully that answered your question, Matt.
Okay. I thought I saw a hand there, but I don't see it anymore. So if there's anybody else who wanted to raise a question, by all means. In the meantime, I did want to talk a little bit about the foundation implications of having wetlands in the area of study here. So as an engineer, like if you ask us to design on a wetland or near a wetland, like we would take on whatever challenges it may be. It's just good to understand those implications and the challenges that it comes with. So typically, when there are wetlands on a site, there's potential for loose saturated material below ground surface. Even if we're building next to a wetland. So after you determine those setbacks, the geotechnical drilling investigations will confirm that presence and extent of those loose saturated material. But if we do have to design around that, um, obviously, like the challenging conditions, you'll have to come up with more complex solutions as well, which may have some cost implications. There are more complex studies as well that we would need to do to come up with those engineering solutions because um, in the presence of loose saturated material, you have to think about like settlement, consolidation, like throwing all these words out there. There could be some slope stability implications as well to your structures. So there's a lot to consider here from a foundation standpoint, and it might involve a lot more investigations.
Sorry, before you move on, Angelica, I just wanted to go back to Peter's
Yep.
question. So one thing to maybe just, or sorry, Matt's question, one thing to maybe think about a little bit on the insect side of things, once again, there's definitely a lot of vulnerable insects, and what is a more going to be at the detailed design phase, more of like an operational consideration. Um, we know that the population of a lot of the common pollinators is declining: bees, butterflies, moths. And one positive thing to say is that we know that a lot of developers are trying to implement features into the site where they would be promoting the growth of wildflowers or other things of that nature that will promote a habitat for pollinators. And including that in your site design really kind of gives you a more fully sustainable site. So something to consider. It doesn't directly like, basically, if you can create habitat as opposed to destroying it, that is obviously a huge positive. And from a regulator standpoint, they quite often like to see proactive measures like that put in place. Back to you, Angelica.
Okay. If there's nothing else, we can move on to the next topic here. On the next slide. Site selection and topography. So the second item here to consider when you're looking for an appropriate site to choose for your project is your racking technology and other technology that needs to be considered, because they would have their own grading tolerances. So not all racking systems are created equal. There are pros and cons for each, but if you are anticipating more challenging grades, so that's one of the things you need to fully understand for all your racking system options. Site topography, and if you do need to do some grading activities, there's a lot of implications that comes with grading. We worked on a number of sites before where there has been some major grading activities, and it required a lot of putting artificial systems in place. But one of the things is, as soon as you have to disturb the natural vegetation on site, not only are you promoting increased erodibility of the site conditions, but you're disturbing also like the natural water flow regimes on site, and you might have to make up for it by potentially upgrading whatever the infrastructure features or the natural controls are in place for sediment erosion. So one of the things is understanding the current sediment erosion controls in place, and potentially having to adopt more advanced infrastructure. So we recommend having a full stormwater management study, and to understand the current regimes. And if you do need to adopt new systems to increase the flows, there are requirements if you need to increase the flows offsite. So for example, there are MTO requirements for ditches around the site, and it could introduce a lot of other complications during the process. If you are removing a lot of material for grading purposes, then you need to think about where to bring that material offsite or to neighboring sites. What else is there? Is there anything else I'm missing, or Ash? I'll let you chime in there.
I think you talked about, which we're going to talk a little bit more actually during our next session. Yeah, the stick up, or the
yeah.
alternative ways to kind of deal with this problem beyond grading.
Right. Yeah. So beyond grading, if you need to adjust your post stick up heights for, like, you need to think about the connection to the racking systems and the implications it has on the loads that are being distributed to the piles. So it might take a bit more delineation on site for different foundation options, because as soon as you change the stick up height across the site, it will change your load distributions, and there's different ways to optimize that from a foundation standpoint, but it will include having different designs. Any question? Yeah, go ahead.
No, I was going to say exactly. Go ahead, Jelka.
Yeah, are there any other questions on this topic here? There we got one. In order to understand the water flow on site, do you recommend a hydrology study? And at what stage of development do you recommend that?
Okay. Do you want me to take that, Jelka?
Yeah, go for it.
So, yeah, very, very, very good question. And what we would recommend is a couple things. So number one, you obviously want to get your civil engineering, geotechnical structural consultant on site sooner than later to just do a visual observation of the site. There's a lot of public topographic data that can help us determine the existing conditions. However, seeing the site in person really does give us a ton of justice in terms of the conditions at the site. One of the things that you want to be determining at the early stages when you're looking at the topography of the site, which, depending on your observations at the site, it may be appropriate in a lot of cases. And this is going to be the case in Ontario. Like for us that's been working in Canada extensively, Ontario is a very, very different environment than the prairies of Canada. Prairies of Canada are flat. Everybody knows the joke that you can see your dog run away for days. That is not the case in the Canadian Shield or in the moraine deposits of Ontario, which naturally are very, very hilly, very similar to the photo we actually see here in this slide. This photo is not particularly in Ontario, but it's upstate New York, which the topography and geology of upstate New York is very, very similar to Ontario. So what you want to be assessing when you're looking at topography is, could we maintain the existing topography as is based on the tolerances of the racking system? So as you all know, there is dozens and dozens and dozens of racking systems out there. Some of them are a lot more forgiving when it comes to topography. Some of them are not. Those that are much more forgiving and can give you more tolerances mean that you don't need to do as much grading. So one of the things that you need to be considering is you need to be selecting your racking technology. When you select your racking technology, you need to be considering the actual grading implications it has on the project. And ideally, you're selecting a technology that can minimize the grading requirements. If you select a technology that requires significant grading requirements and it's very evident from the topography at the site you are going to need to do some grading, that is when it would be appropriate to do stormwater management or stormwater management studies, hydrology studies. You're basically going to do a water balance study to determine the peak discharges at the site to verify if what changes will be made from the pre-construction condition to the post-construction condition. So, going back to your question, Sebastian, you want to do your environmental setback considerations. You want to take a look at the topography. You're more than likely going to want to do a topographic survey, and you're going to want to, if not have your preferred racking supplier selected, you're going to want maybe one or two, but the assumption there that if you are selecting more than one is that from a grading tolerance, they can accommodate the same level of grading so that you are determining based on those grading requirements if you need to do any cut and fill. And if you do need to do cut and fill, that's when you need to be thinking about detailed stormwater management studies. Does that answer your question, Sebastian? Okay, perfect. Okay, so moving on to the next question. What factors should be considered for the lifespan of posts and structures? Are there specific specifications stated for the lifespan of zinc coatings? I don't know if you want to maybe briefly touch on that, Jellica. We're going to talk a lot more in detail about structural considerations next week, but maybe you can just kind of briefly talk to that.
Yeah, so there's a number of factors you can consider here. So talking to the zinc coating, so one of the things that we have to consider from a foundation standpoint is corrosion. So understanding the corrosivity of the existing soils on site, and how much that would degrade the steel structures, so that will inform the lifespan of the posts and structures. But typically, if the project requires a certain design life for the structure, so typically that's around 25, 30, 35 years across Canada, then we would just adjust the posts to accommodate that. So there are other solutions like such as sacrificial thickness, to make sure that it lasts for the preferred design life of the project. There are other implications. So there's climate. One of the things that we will be talking about on the second part of this webinar series, because that's one of the huge topics, especially here in a cold climate country, and the implications of climate warming. So biggest drivers of foundation design is frost. So understanding how the weather changes over the design life of the structure is one of the biggest things that need to be considered as well. Does that answer your question there? Okay. We can look at the next question here. Perfect. Thank you. And yeah, another comment here from Juan. I would add that the racking height adjustment could provide some added flexibility to meet module to ground clearance. Yeah, exactly there. One of the things that we will be covering on the second part of the webinar as well is the racking height adjustments, and how that has implications to the foundation design as well. But yes, that's another option to prevent grading on site.
Yeah, and just to add to that, I'm happy you brought that up, Juan, because there was a lot of focus kind of on the answer of my question to Sebastian on selecting your racking technology. And your point is another, very, very, very relevant and appropriate point as it relates to selecting the technology so you can understand the flexibility. A lot of times we've seen some developers or contractors look at a potential racking system and not considered the full holistic considerations of implementing that system on the site. And the one area that we see a lot often forget is the ability of that system to deal with adjustability and then grading. Because if those two items are not considered, there could be a very, very, very large cost that has not been considered when selecting the technology. Beyond all the other stormwater related items that Jellic and I spoke to, there's also the cost of the construction that isn't being adequately considered.
Okay, I think we have one more question here from Jean. What are site prep considerations when dealing with a forested area?
So with a forested area, one question we very commonly get asked, and theoretically you probably could do this, but we would really, really, really discourage it because I would consider it a potential risky situation you're putting yourself in is, if we do go and clear cut the forest to make room for the solar facility, do we need to consider removing stumps for installation of foundations? And so, like, if you're removing trees to improve shading considerations, that area could be left with stumps in it. However, if it's in an area where there will be foundation installed, we discourage fully from leaving those stumps in place. So you would need to clear cut the forest and you would need to degrub the stumps. There is a little bit of a fine balance there, unfortunately. As Jellica mentioned, maintaining vegetation is pretty critical. Actually, it kind of reminds me of a project I worked on in my previous life, like almost a decade ago during the early fit program. And, contrary to recommendations from the engineering team, the contractor took it upon themselves to do a pretty extensive earth moving program. And in doing so, they didn't have a final cut, fill, balanced grading plan to work off of. So there was a little bit of field fitting taking place. In doing so, they ran out of fill from site. And so their options were to stop grading or to import fill. Or there was actually a third option, which I wouldn't really consider an appropriate option, but this is the one they took, is they would use the topsoil that was stripped from the site for grading. So they ended up using topsoil in structural areas to act as like structural fill material. But in doing so, it meant that there was no more topsoil left to reinstate the organic layer on the site, and therefore vegetation didn't take. Fast forward into operation, and this site saw substantial amount of erosion of the surface, to the point where the neighboring farm actually had 0.5 meter of silt deposited on the site, which negatively impacted the adjacent site because it was still being proposed to be used for agricultural purposes. So that's just kind of a worst case scenario of what could happen if you eliminate the vegetation. That being said, you want to get rid of the heavy organics, particularly the roots of any trees, but you want to try to maintain as much vegetation cover as possible to maintain the natural erosion protection at the site. So hopefully that answered your question, Jean. And then maybe the next question, I'll maybe leave to you, Jellica, about geotechnical investigations.
Okay, so geotechnical investigations, the question is, how many borings do you plan for? I know it's dependent on the geology, but is there a general rule of thumb based on the megawatts of the project? Yeah, there's a few things to consider here. One of the things we ask at the start is, what is the stage of the project? Are you looking to just do a high level feasibility? Or are you looking to supplement a current, just to supplement a bidding process, or are you looking to go straight into detailed design and construction? And what are the current timelines and economic considerations for the project? Because for us, like, we can do it as a staged approach. So if we are still in the early stages, we can do less just to get a high level picture of the site and to help us come up with a more tailored plan for the next stage of the project, because there are different geotechnical solutions, and we would always, there are different stages such as like pile testing. So yeah, maybe from a general rule of thumb, um, I don't know, actually want to throw a number in there, but
Yeah, I think it's very, like Jellica said, very dependent on what the objective and goal is.
yeah.
You know, if you wanted, George, you're more than welcome maybe to even reach out to us offline. Our contact details will be at the end of this presentation, and maybe we could, you know, talk through that a little bit more
Mhm.
to give you a, you know, more concise answer on that.
Yeah. And maybe added
Okay.
to that, if like based on all these like site selection, topography, based on the current information for that specific site, if we are anticipating a more complex condition, then it might mean that we would propose more than the typical. But if it's just like a straightforward flat site, then yeah, we might lean on just the general rule of thumb. So yeah, definitely site dependent here. Um, okay.
Okay. So the next
Uh,
question, Brendan is asking, what is the sweet spot range or dollar per effort rule of thumb for funding geotech and pile testing programs early in the development phase for the budget concise solar developer, even though we know that EPCs like to redo some of the program work using their own methodologies after EPC or pre-construction? Yeah, great question. I mean, one way to look at this, Brendan, is you hiring a firm that you know is kind of reputable in the field and hopefully would not result in rework at the EPC level is one way to go about that. But then in terms of like a rule of thumb, hard to give an exact rule of thumb, but having an openness for a staged approach. You know, one of the challenges with geotech that's very, very different than structural engineering or electrical engineering is that everybody describes geotechnical engineering as the black box of the civil engineering world. And what they mean by that is that um, we make a lot of interpretations. So you may have a 100-acre site, and we may be determining what's happening around that 100-acre site from very, very small look into what's going on the site. You know, a borehole is only 4 to 8 inches in diameter. A test pit's about 1.2 meters by 1.2 meters, 4 feet by 4 feet. So you've got a very small snapshot as well. So being willing to adjust your program so that being able to adjust your program so that you can get the right information is something you need to be open to. And so that could mean that, you know, you're spending $20,000 on geotech on a site. It could mean that the right number is $100,000 of geotech on site. Now, typically, if you're looking at this from a de-risking standpoint, naturally, if you have more complex conditions and you've got to do a deeper investigation, you know, something along the more lines of like 100,000 versus 20,000, just as an example, you can imagine that that probably results in a more complicated foundation installation, more specialized foundation design, which usually comes with a larger price tag. So if you're taking the staged approach and you're kind of listening to the implications of the conditions, a lot of the times you're actually kind of, you know, staying in that lower range, because what's happening in these early stages is that we are determining that certain sites may not make sense to proceed with at a development level because of the geotechnical risk. So apologies, I don't think I gave you a dollar per effort rule of thumb, but hopefully that, you know, gave a little bit of a better understanding as what should be considered when you're kind of developing a program. And I mean, one thing that I will say, usually early stage, then usually do early stage, then EBC. Yeah, that's the stage we're talking about, Brendan. And the one maybe other takeaway from that, going back to your original question, is really need to have your consultant give you feedback at every step. And this is, you know, being somebody that does pride ourselves in being kind of experts in this field, we do really push the stage approach. What we see in a lot of cases when we get reports from other consultants that may not be as experienced in the field is that they will propose a very large program, and it'll have 10, 15 steps, but they didn't give any feedback to the developer as they went through those steps. And in some cases, maybe it didn't make sense to go past step 5 to step 15 because, yes, that's what was proposed and that was asked for, but based on the change in conditions or the additional knowledge that has been learned from doing a site visit, doing a topographic survey, from doing a geotechnical investigation, and maybe thinking about doing a pile testing program, is that all of a sudden the economics of the project have not been considered. So, you know, really think it's important to look at this from a staged approach. Would really recommend that, you know, as I believe, you know, Brendan, development dollars are very valuable, and trying to take the minimalist approach to really de-risk what could go wrong as a worst case scenario and what's the constructability of the foundation is ultimately what we're trying to determine. And, you know, that could be $1 a watt, that could be 10 cents a watt. You know, it really depends on the site conditions.
Okay.
Question about access roads. Maybe we'll just talk about that because we do have some time to talk about site access. Maybe
on
you
the
can.
next. Yep. Okay. Yeah. Why don't we wait to answer that on your next slide? Are there just doing a time check here? Maybe there's another quick question here about borehole depth for solar projects. Really quick rule of thumb question. Typically, we go down to 20 feet max for solar design. In some substation areas, we may go down to 30 feet. Very high level, but of course, there might be some more tailored approach for different solutions there.
I'm just going to quickly go back to Brendan's comment for 30 seconds. Okay. Risk for accelerated corrosion. Yeah, and maybe we'll talk about the corrosion question next week if that's okay. But you know, I'm really happy you're bringing this up, Brendan, because we all know that DevEx money is very valuable, and exactly to your point, less risk dollars being priced in by EPC, better CapEx certainty. So having better CapEx certainty, like that goes with having a developer that is somewhat flexible in the program, understanding that there's a general roadmap of collecting the information, but that it only makes sense to spend the dollars if it involves de-risking, right? The goal is to put documentation in front of EPCs that they would be comfortable with and that they can interpret and use in a positive light to come up with the design that they're most comfortable with. And like I said, that may involve going down a different path depending on the conditions. So that's why the staged approach, and not just giving a 1 through 15 procedure and say we're going to do all this, because like I said, there's a lot of cases where it may not make sense to do steps 5 to 15 after you've determined some additional information. You may be looking to do 5A, 6A, the alternative to those steps. And that is where it's important that there's a constant communication between the engineering consultant and the developer and their team to ensure that they understand where the gaps could exist and where the implications of not doing this certain alternative test could arise. Give best bang for the buck. Yeah, exactly. So that's good. Okay, maybe Jellica, you can take one more question here, and then we'll go to the next slide.
Okay. Let's do this. What are your thoughts on using helical piles for solar panel support foundations? Are there any investigations specific to these types of foundations that you recommend? So the first stage, before we start looking into different foundation pile type options, is the geotech. So we would look at the geotech first, and if the geotech suggests that there are some presence of cobbles, boulders, or maybe shallow bedrock, that could impede the installation of the helicals. On the flip side, if in the absence of that, then yes, helical piles are one of the main options we look at. There are definitely other factors as well. There are different types of structures that could be more appropriate for the site, such as ground screws or driven piles. Typically, driven piles are dollar to dollar, like cheaper for material. However, obviously there are geotechnical considerations as well. And there's also the racking side of things. So it depends on what cross section is the preferred connection to the racking system. That can also determine the type of piles. So lots of things to consider there. And that will depend on a site-by-site basis. Okay, are we good to move on to the next two topics here? I want to make sure we leave some time for the next two slides. Okay, there we go. Over to you, Rash.
Yeah, so real quickly, we'll speak to this. So there was some questions about access road considerations. So there was some recommendations there about minimum access road size. So there's usually, you want to check with your local municipality. They, in a lot of cases, will have geometrical requirements for access road design, minimum terminal radiuses onto the site. However, from a practical standpoint, it may not always make sense to just use the minimum. You need to be considering what type of construction equipment, what kind of delivery equipment will be coming on the site. If you have a big 18-wheeler coming on the site and you've got just one straight shot 4-meter road, is it realistic for that truck to be able to turn around on the site and leave? So those are the considerations you need to be doing. That's a pretty typical road design exercise where you're checking your maximum turning radiuses of the proposed vehicles to come on the site, and ensuring that they will not get stuck. On an off-site side of things, I'm not sure if people are familiar with the concept of half loads. We actually just did a blog on it. So if you don't, if you aren't familiar, maybe actually Livia, you could put a link to that blog in the chat for those that aren't familiar with half loads. But essentially, what half loads are is that in northern climates where the ground freezes in the winter, when you have thawing happening in the spring, the ground beneath the road is frozen and it starts to thaw from surface down, meaning that a portion of that road is frozen and a portion of that road is thawed. When that material below the road is frozen, it doesn't have the opportunity to drain, meaning that the material that is thawed typically is oversaturated. And when soils are oversaturated, they have a lower effective stress, meaning that they have a higher probability to deform. Basically, if you've seen tire ruts in roads, that's a function of deformation. So for a lot of you that live in Ontario, I'm sure you're kind of familiar with the half load concept, or maybe you're not, and you've probably noticed though that when you're driving maybe on a smaller country road, that there's a lot of potholes developing during the winter, during the spring months, and that's a function of loss of strength of your subgrade and granular materials in a thawing condition. And so in some cases that may create restrictions where you can't bring a full load of concrete, you can't bring a full truck of aggregate, meaning that it might be 2 or 3 more loads to get the same volume of aggregate to the site when compared to when half loads are not in effect. So, in some cases, you need to kind of consider that when you're doing scheduling. Electrical connections, having a good understanding of where the substation is going is important. Jellica did speak a little bit to, the geotechnical investigation in the substation or for other electrical equipment. So, that is very important to kind of have a good understanding about ahead of time. And what about the surrounding infrastructure, specifically transportation? That's where the half loads come in. And actually, in some cases, it's not just half loads. We all got to keep in mind that in a lot of cases, a lot of these sites are very, very remote, meaning that the infrastructure that's leading to them is not always the best quality for construction equipment. Okay. I think that would have answered all the questions about transportation in the chat, so we're probably good to move to the next slide. And then finally, the last thing we want to talk about today, before we wrap it up for this afternoon, is operational considerations. So in a lot of cases, we are only considering the cost to build the facility. We are not considering the cost to make sure that the facility is running appropriately in the long term. So, one thing, like we talked about access roads, it's not uncommon for you to need to have to access these sites once, twice, maybe a couple times a year to do regular maintenance. And if you can't access an area, you can't always do maintenance or inspections on it. So, making sure that there's easy access throughout the site is important. That doesn't only mean roads. That could mean, does a certain portion of the site flood in the spring, and does that mean that a quarter of the site is not accessible in the spring? Those are the types of things that you need to be thinking about. Looking at monitoring systems, particularly when utilizing a single axis tracker, admittedly, I'm more of an advocate for a fixed tilt system than a single axis tracker. I know that some of the electrical engineers in the room would probably disagree with me because they're looking at this from a generation electrical standpoint. Looking at this from a pure structural civil standpoint, structures that don't move are a lot less susceptible to stress and strain and having problems arise. One thing to one thing to keep in mind with a lot of single axis trackers is that it's monitoring of their performance kind of in lifetime is somewhat important, and having an understanding of certain weather systems coming through the area is important. Like, for example, we've all heard the horror stories in the last couple of years about hail. So, having maybe selecting a system that has a good hail mitigation strategy is something you want to consider. But the one thing to keep in mind with hail mitigation strategies is that it typically will result in the structure need to be more robust to kind of resist these conditions. There's like different strategies out there for hail, but most of them are very similar in the sense that they're just backtracking the modules and putting them in a position where they're least susceptible to hail. And sometimes that means if they're least susceptible to hail, they're most susceptible to wind, which means that the moment and the loading that's acting on the foundation is going to increase. And we'll talk about that a little bit more next week. And then finally, always a hot topic. Thinking about circular economies. One day, someday, some of these facilities may need to be decommissioned. And what is the disturbance to the site when decommissioning? One positive about helicals and ground screws and other foundations that you torque into the ground is that they can be easily torqued in and torqued out, meaning that you don't have any concrete, you don't have a driven foundation, which in a lot of cases would need to be excavated out of the ground, which could create a large disturbance. This really minimizes the impact at the end of life of the project as well. I believe that takes us kind of to the end of our presentation. Appreciating we only have 2 minutes left. Maybe we'll open it up for last question, maybe 1 or 2 questions. We do have part 2 of this webinar taking place next week. Hopefully we'll see a lot of familiar faces from today there for part 2. And if you've got any greater or larger conversations you want to have on this topic, feel free to please reach out to Jellica and myself.
I think there's a few questions
Go for it, Jellica.
that we missed in there. Which one should we start with? Okay. I think there's one from James here. Are open columns such as Schedule 40 pipe at risk for accelerated corrosion because both sides of the steel, inside and outside, are in contact with the earth, as opposed to I-beams, where the steel is only in contact with the earth on the outside? Yeah, there is a point to that. We do consider both sides of the steel when it comes to a pipe for corrosion. There are other overarching factors as well when it comes to choosing between pipes versus I-beams. So we wouldn't leave it at just the corrosion side of things. It comes down to constructability and drivability and other capacity factors as well, because there are advantages to having a pipe versus an I-beam as well. I wouldn't get into that. Maybe on our second part of the webinar, we can go in a bit more detail there. Okay, I think there's another quick question here from Arun. What is the minimum drilling depth in a rock strata if we encounter one while drilling? So we do drill to refusal or until we reach our target maximum depth, which I mentioned was the 20-foot rule of thumb. Drilling through rock does require additional or more specialized equipment. So that's one of the things we would need to consider is, do we need to drill through the rock? Because if we find competent material at shallower depths, typically that would be enough. If there's a need to drill into the rock, then we would have to adopt other procedures and use other equipment to core through the rock. So it does depend on the subsurface conditions and the overburden above the rock. Okay. Another question here, do you encounter any horizontal directional drilling for solar projects? Arash, do you want to take on that one?
Yeah, absolutely. So from a horizontal drilling standpoint, a lot of that will be site specific. I have seen it done. Typically, it would be for more critical pieces of infrastructure, such as your interconnection to the transmission line. It would be less likely to be completed for, small, low voltage, medium voltage lines within the actual array itself, but it's not uncommon. If you've got to cross like a wetland or some sort of water feature, or even like if you're in northern Ontario and you're in like Canadian Shield and you got very, very hard rock, it's not uncommon to tunnel the final interconnection high voltage line to the transmission line using horizontal directional drilling.
Okay, I think that was the last question here, and it's also time's up. So yeah, if there's anything else, we can feel free to contact us through our information that's shown on the slide here. And we'd love to see you again on the next session next week.
Yeah, email also will be sent out for promoting part 2 of this event that you can register with. I've also put the link for part 2 registration in the chat.
Well, thank you everybody for joining us.
Thank you.